or other equations. So we looked at this linear quadratic. Of course, we know them by heart by now. We looked at quadratic informal and look at rational. What other topic should we look at now? Very good. Piecewise defined function. Awesome. So that is from chapter 2. Good topic. Good topic is going to be on the final. Let me find one from the book, or we can invent one. There is no problem there. One with 2 branches, one with 3 branches. You're going to have one with 2 branches. It's good enough. Ready? Okay, let's invent one. Sorry. Well, let's say negative x plus 2 for x less than or equal to 1. And let's say x squared plus 1 for x greater than 1. Is this a piecewise defined function? What do I have to determine first before I present the table of values? What is my first concern every time I'm asked to graph a function? My first thought. Exactly. Awesome. So I look at this, and I know that it means between negative infinity and 1. I look at this, and I know it means exactly what? Very good, of course. And now I can identify the domain. I need those symbols in the table. That's why I'm doing this anyway. Yes. So the domain is all real numbers. There is, okay, so under 1, I have to have 2 symbols. I have to have this symbol facing left and this symbol facing right, and they're touching each other, the 2 symbols. What function do I use for the first part? What function do I use for the first part? Yes, please write it in. Can I let you 3 minutes to work on this till I run to the bathroom? My apologies. So put the function in and look at what one of them is linear, the other one is quadratic. Give it a shot. Be right back. Apologies. Thank you for being patient. So we have the negative x plus 2, and we have x squared plus 1. Okay, this is linear. I would plug in 0, and I get 2. I would plug in 1, and I get 1. I need 2 points for a linear function. That's good enough. I plug in 1, I get 2. I plug in 2, 4 plus 1, 5. So far, so good? Okay, so let's graph. From left to right, I see 0, 2. I see 1, 1, which must be a full point, and I know that this is linear. And it's done. On the right-hand side, I have to start at 1, 2 with an open point. Move on to 2, 5, 3, 4, 5. And I know that this is not a straight line because it's x squared plus 1, and I know how it looks. So this is our function, and I would like to determine its range. Perfect. From the lowest y value till the largest y value, and with a bracket. Very good. Very good. Thank you. So let's choose something else. So do we need more examples with piecewise, or is this clear? If we need more, we can look at more. Okay. Transformations we'll be doing all along everywhere, with log, with exponential, but we can go back to transformations as well. Polynomial functions, rational functions, graphs. Yes, the end of chapter 3. Online, the end of chapter 2, sorry. Okay, so let's look at page 332. Let's look at 59. X squared minus 2x plus y squared minus 15 equals 0. The only thing that I would like to add to my list is the 4 methods of solving quadratic equations. And we discussed them in chapter 3. Yeah, so I'm going to add them to test 2. I'm going to put in one more line. So quadratic equations. And in parentheses, factoring, completing squared, taking square roots, and quadratic number. Okay. So 59 on page 332. We're asked, is this a circle? I have no clue. If I can present this equation like x minus a number squared plus y minus a number squared equals a positive number, then I will say yes, because this is the equation of a circle. If I cannot present this like this equation, if I cannot complete the square and present it like this, or the right-hand side is 0 or -5, I'll say no way, this is not a circle. So how do I start? Yes, we can do that first. So since y squared does not have another term with y, I already have this situation. This is clear. How much is k? K is the number that I subtract from y. What is k here? What is the number that I subtract from y? 0. So k is 0. Good. So, but I have to work on this. And I know that I can complete the square. X squared minus 2x, and it needs a third term that I will have to add to both sides. Middle coefficient. We divide that by 2. We get -1. We square -1. When we get 1. And that is the number that we have to add to both sides. So then, what does x squared minus 2x plus 1 represent? And 15 plus 1 is 16. So x squared minus 2x plus 1. Our handout from the first day of classes. What does that mean? So we were able to present this given equation like this. All we have to do now is identify the center and the radius. So what will be the center of this circle? Yes, the center of the circle is indeed 1, 0, and the radius is? Perfect. So in case we're asked to graph it, we will. We plot the center first, which is 1, 0, and we determine 4 points, east, west, north, south. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. My graph will be far from being a circle, but a fair attempt. Very good. What if I'm given, let's say, the equation 48 to identify, let's say, x plus 4, everything squared, plus y plus 5, everything squared, equals 36. Here I'm only asked to identify the center and the radius. I'm not asked to do anything else. And maybe graph it. So what will be the center of this circle? And the radius? That's it. Very good. So let's take a look and choose out the topics. We want to look at the absolute value, equations, inequalities, maybe, or which topic will be next, do you think? Any preference? Which one? This is linear equations, Gaussian elimination, Gauss-Jordan. Very good. So these are in section 6.1. Very good pick. Okay. Page 631. Let's choose 30. I don't know if we did 30. If we did, it's okay. So 2x plus y equals Oh, I'm sorry. So 30. 2x plus y equals z plus 1. 2x equals 1 plus 3y minus z. And x plus y plus z equals 4. So this is a system of 3 linear equations in 3 variables. We're asked to solve it using Gauss-Jordan. My first question to myself is this system in the correct order? Is it ready for Gauss-Jordan? Correct. The answer is correct. No, it's not. So I have to rearrange the whole thing as 2x plus y minus z equals 1. The first equation, everything in order from left to right. In other words, x, y, and z. And then equals 1. Then 2x minus 3y plus z equals 1. And then x plus y plus z equals 4. Now I can write the augmented matrix. What is the augmented matrix? By columns. 2, 1. 1, negative 3, 1. Negative 1, 1, 1. And 1, 1, 4. Remembering that what is important here is to stick with a sequence of steps. One more time, the sequence of steps is this. I get the 1 of the first column, and then it will help that 1, that number, 1, will help me get the zeros underneath. Then I move to the second column right in the middle, and I must get 1 in the middle. That 1 will help me get the zeros above and below. And then the last column, I have to get a 1 in the last row of the third column. And that number 1 will help me eliminate or get the zeros above. This must be the sequence of steps, and we cannot deviate from it. Okay. What do you think? How do we get a 1 here? Yes. Yes, I will make row 1 into row 3 and row 3 into row 1. That's the easiest thing to do. Just swap. So we have 1, 1, 4. 1, 1, 1, 4. 2, negative 3, 1, 1. And 2, 1, negative 1, 1. Be careful when you copy because it's very easy to make an error. So I copied 2, 1, negative 1, 1 in the third row, and I copied 1, 1, 1, 4 in the first row. Good. So now I accomplished this, but I want to get now the zeros, corresponding zeros under that 1. And 1 will help me do that. So I will definitely have to use row 1 and add it to row 2, and row 1 and add it to row 3 after I multiply row 1 by something that I need to. So what do I need to multiply row 1 by to eliminate 2? Negative 2. What do I need to multiply 1 by to eliminate 2? Negative 2. Which row do I have to copy now because I'm using it, and it cannot change. If I'm using it, it cannot at the same time change. Row 1, indeed. Very good. So 1 times negative 2 plus 2. 1 times negative 2 minus 3. Negative 5. 1 times negative 2 plus 1. Perfect. 4 times negative 2 plus 1. Very good. Ugly. Very ugly. But it is what it is. 1 times negative 2 plus 2. Negative 3 times negative 2 . We multiply. 6 plus 1. 1 times negative 2. Negative 2 minus 1. 1 times negative 2. Negative 2 plus 1. Negative 1. Very ugly. Yes, Marcus, if you think that there is an error, you may be right, I may be wrong. Yes. Yeah, let me do this again. Just double check. 1 times negative 2 is negative 2 plus 2 is 0. Negative 2 minus 3 is negative 5. Negative 2 plus 1 is negative 1. Negative 8 plus 1, negative 7. Yes, yes, I'm getting to that right now. So far, so good? Yeah. Okay, I'm just checking everything now. 1 times negative 2 plus 2, 0. 1. Ooh, see? 1 time, I looked at negative 3. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. Thank you. Thank you. 1 times negative 2 plus 1, negative 1. 1 times negative 2 minus 1, negative 3. 4 times negative 2, negative 8, plus 1, negative 7. Negative 8 plus 1, negative 7. Okay, not as ugly as I thought. So we accomplished all this, but now I need in here, right in the middle, I need a 1. And I will first divide row 3 by negative 1 and then swap the rows. I can now no longer swap with the first row because this 1 will be destroyed. So I will divide row 3 by negative 1. And I have 1, 1, 1, and 4. And now I have 1 more minute. And then 0, 1, 3, 7. And then 0, negative 5, negative 1, negative 7. So we divided row 3 by negative 1, and we made row 2 into row 3, and row 3 into row 2. Okay. We can stop because I have 3:15, or we can do it at home, or we can finish it on Monday. Whatever you want me to do, I'll do it. Okay. I would like you to finish it and try to finish it and see what you get.